So are we okay with that? The idea here, so if I, basically now you want to take 8765 and divide it by 148 and take the remainder again. Anybody have that for me? Negative 9, I'm going to put them into groups of 148, and how many are left over? I need to have at least 2 people get the same answer. Anthony says 33. 33? Oh wow, lots of consensus. Okay, so this is 33. Okay, beautiful. So this is mod 149. Okay, and now you just have to start calculating some powers of negative 9. There's no other way to do it. Probably I would cube this thing first and reduce it, mod 149. So you want to, as you're taking powers, reduce as you go. So this is congruent to negative 9 cubed to the 11. So can somebody tell me in mod 149 what negative 9, negative 9 cubed is, or 729?
133.
729. And we're doing this in mod 149.
133.
Or negative 16 might be better.
Oh yeah, that looks better. That looks better.
So negative 16 to the 11. Okay. So 9 cubed is, was that 9 cubed or negative 9?
Negative 9 cubed, so it's positive 6.
So it's positive 16, did I do that wrong? It should be positive, right? Okay, positive 16. And 16, of course, now I could square that. Gives me 256. 16 squared is 256, and in mod 149, that's going to be 107.
Or negative 113.
So 107. So this is going to be 16 squared to the 5th times 16. So 107 to the 5th times 16. How about somebody, can we get 107 to the 5th on a calculator?
You just want the answer?
Huh?
You just want the answer?
Yeah, do you have the answer?
Yeah,
I'll take the answer if you have it.
1,007.
1,000 what?
Well, no, never mind. What are we doing?
107 to the 5th
Boy,
power.
I feel so much confidence there.
107 to the 5th power is 14
Okay, the
billion.
answer's 30. Sorry,
Huh?
answer's 30.
For this whole thing? Mod 149.
Yeah, for the original thing we were doing. Yes, for that one. For the mod 149.
Okay, that's what I want. I want mod 149. Okay, great. So we have 30. I'm going to take Bora's word for it.
Everybody can blame me.
That's right. So then that means that our value for x, so x is congruent to 0 mod 29, and it's congruent to 30 mod 149. So you have a little system to
It
solve.
is 30. Sorry, I just wanted to check. I just wanted to check.
30 for the second one?
Yeah.
Okay, good.
I
Two
just
people
wanted to
agree.
check.
So I've got to be in pretty good shape. Okay, and now you just use the Chinese remainder theorem. And the nice thing here is, since a1 is 0, I don't even worry about n1 or y1. So I just go straight to a2, which is 30. n2 is 29. And y2 is the, so I have to take 29 times y2 is congruent to 1 mod 149. Right? And now what do you have to do? I think I did this part. You have to find an inverse for 29 in the world of mod 149, and I did that and got 36. So y2 is 36. I'm pretty sure I got that part right. So that you do that by using the Euclidean algorithm. Right? You take 149, divide by 29, run the whole thing forward and backwards. Okay, so then the final answer is just going to be 30 times 29 times 36. 30 times 29 times 36, which is 31,320. So x is congruent to 31,320, and that will be modulo 4321. So we want the remainder. Come up with an answer that's less than 4321.
Sorry, how'd you quickly figure out the Y2?
I didn't do it quickly, I did it last night. I'm just telling you the answer, because it's just the Euclidean algorithm, forward and backwards. And I don't wanna spend too much of your time on it right now. So then I just have to reduce this. Can somebody reduce 31320 and mod 4321 for me?
This is supposed to be 1,073, so I'm gonna go with that.
Is that what you got? It's 1073? Okay. Yeah, that sounds good. That sounds good. That sounds familiar. Quick question here, before I go any further. Could I have just, because I did this with the CRT, could I just do this with the Euler's generalization of Fermat's little theorem? I've already seen this problem. I know. So the Euler's generalization, which we haven't really talked much about today, just says that a to the phi of n power congruent to 1 mod n. So could I just directly use this?
No.
So the n would be 4321, which we said was 29 times 149. And of course, I can figure out phi of that would be 28 times 148, right? You just subtract 1 from those primes. So this exponent, I could use that as a power, right? 28 times 148. So, can I use the Euler's generalization?
No.
Okay, why not? Are you getting the wrong answer? You should be getting the wrong answer. That would make me happy for getting the wrong answer. Yeah. So why can I not use this? That's the thing, right? In order to use this Euler's generalization, the greatest common divisor of a and n has to be 1, but didn't we just figure out that there's a common factor of 29 in both, this number has 29 as a factor of 29 in it, and then so does the mod. So be a little careful. This one, you really are better off splitting it into two separate equations, and then the mod 149 one is perfectly fine. There's no common factors of 149 in this number. But if we had tried to use the Euler's generalization and meet directly here, it would not have worked out, because the a and the n have to be relatively fine. That make sense? Okay. All right. So that actually wasn't as bad as I thought. It's mostly just computational. Mostly just a little bit of calculations. Just make sure you're proficient with your button pushing here. Do your calculator stuff pretty well. Let's see. I had that one other problem. You want me to do this other problem? I'll write down the answer and let you try it. Does that work? As soon as I write down the answer, you're going to want me to do it.
Oh,
But I won't do it now. I can tell you're tired. I'm not tired at all, though, just so you know. Just for the record. I haven't been so awake all day. All right, you're not going to like this.
Just a disclaimer.
That's my disclaimer, but I'll tell you the answer. And then if you want, use it as another thing you can practice on, and then you can come ask me. I got the solution, it's not that long.
Can you write the problem again? Can you
Oh, can I write the problem? Oh, it's on the sheet. It is problem number 7 on the handout.
So it's show which
Find, so yeah, find for which primes greater than or equal to 7 is 15 Legendre symbol and mod p equal to 1. And the answer is, if and only if p is congruent to plus or minus 1, plus or minus 7, plus or minus 11, or plus or minus 17 in mod 60.
It's a lot of cases.
It's a lot of cases. It is a lot of cases, that is right. Really the reason it's a lot of cases is you have to look, just to give, I won't do the whole thing, but just to give you the idea. You basically have to look at both of these. And in looking at both of these, of course, what you want to do is flip them over. But when you flip things over, you have to worry about whether you need a minus sign or not. And that requires you to know whether P is congruent to 1 or -1 mod 4. So that's where a factor of 4 is coming in. You see there's a 60 here, has a 4 in it, right? And then the 15 is kind of more obvious where that's coming from. So yeah, either these are both 1 or they're both -1. And so out of these 8 cases, there's 8 different cases, 4 of them are going to be ways in which both of these are 1. And 4 of them are going to be ways in which both of these are -1. So, like I said, I worked it out, I sat down, it's not that terrible, but, should I just let you do it?
Yeah.
I'll let you guys try it. Hey, we've got 4 days to practice a lot of things. There's a lot of things that you guys can work on. I'm going to be around a lot, so come on by, send me text messages, send me Facebook messages, you want to know where I'm at, what I'm doing. I'm going to be on campus every single day from now till Wednesday. And thanks for coming. I guess we'll turn this off.
I'm gonna